Welcome dear student and Jai Swaminarayan. In the first lecture of the chapter number 12, we will discuss about what do you mean by the sound. Sound is a form of the energy that produces the sensation in our ears. Second point, we will discuss the production of the sound. How the sound wave are produced. The sound wave are produced by vibrating a object. Vibration of the object to and fro motion of the object produce the sound wave. Third point, we will discuss about the propagation of the sound. How the sound waves are travel in a different medium. Right? The sound waves are travel in all the three mediums: solid, liquid, and the gas. In the form of the compression and the rarefaction. So in the when the vibrating objects are vibrating among their equilibrium position, the air near to the vibration is compress each other and it creates the high density region, and this region is called the compression. So when the vibrating object moves in the backward direction, it creates the low pressure, and this region is called the rarefaction region. So the sound wave are travel through a medium with the help of the compression and the rarefaction, right? And further, in the previous video, we were discussed about the two important characteristics of the sound wave. First one is the sound wave are called the mechanical wave. Why the sound wave are called the mechanical wave? Because to propagate the sound wave, the medium is required, right? So the sound wave are called the mechanical wave. And second important property of the sound wave is the sound wave are a longitudinal wave. Why the sound wave are called the longitudinal wave? In the sound wave, to propagate the sound wave, the particles of the medium oscillate in the direction of the propagation. So the sound wave are called the mechanical wave, and the sound wave are called the longitudinal wave. So dear student, in this video we will discuss the characteristics of the sound wave, right? In the previous video we had discussed the two important characteristics of the sound wave. Sound wave are a mechanical wave and the sound wave are a longitudinal wave. And while the sound wave are propagating through the air, the compression and the rarefaction are produced in the air. So in this video, we will discuss the characteristics of the sound wave. How the characteristics of the sound wave is measured, right? The sound wave can be described by its characteristics like a frequency, amplitude, and the speed of the sound wave in the different medium, right? So while the sound waves are traveling in a different medium, its characteristics is described by its frequency. Second one is its a amplitude and speed. Third one is a speed. Now sound wave can be graphically represented as a wave, right? We know that the sound wave is a one type of the wave. Sound is a one type of the wave. Why it is? So in the sound wave, the disturbance produced by the vibrating object is moving in the different medium, like in the air. If you consider the air, vibrating object is producing the disturbance near to the air contact with the vibrating object, and this disturbance, effect of this disturbance is move in the medium, right? So sound is a one type of the wave, and sound wave can be graphically described by a wave. There is a change in the density and the pressure as the sound moves in the medium. Dear student, we know that the sound wave is moved in the medium in the form of the compression and the rarefaction. What is the compression? The compression are the region where the particles of the medium are very close to each other. It creates the high pressure, right? High density, right? This medium is called the compression. And the what do you mean by the rarefaction? Where the particles of the medium are very far from each other. It has a low pressure and the low density, right? So this medium is called the rarefaction. So consequently, the compression, rarefaction, compression, rarefaction, compression, rarefaction are produced in the medium and the sound wave are propagating in the medium. So here the sound wave is represented graphically by the variation of the density of the medium, like this, right? Pressure or density. So variation of the density of the medium. So as the density is increasing, so this region is called the compression. At the another region after the compression, the rarefaction region, where the density and the pressure is a low. After that, again the compression is produced in the medium, right? After the rarefaction. So here the sound wave are graphically represented by the wave like this, right? Distance between two successive compression or two successive rarefaction is called the wavelength, that we will discuss later on in this video, right? So here the compression and the rarefaction, the sound wave are propagating through a medium. The sound wave can travel through the medium in the form of the compression and the rarefaction. So dear student, what do you mean by the compression? Compression are the regions of the high pressure and the high density where the particles are crowded and are represented by the upper portion of the curve called the crest. So this portion of the wave is called the crest, right? So the compression is a region with the high pressure and the high density, and in this region the particles of the medium are very close to each other. Particles of the medium are crowded, right? And this is represented by the upper portion of the curve. So variation of the density in the upper portion are called the crest, right? So this region is called the crest. And second one is the rarefaction. Rarefaction are the region of the low pressure and the low density where the particles are spread out, where the particles are far from each other and are represented by a lower portion of the curve that is called the trough, right? So this one is the rarefaction region. So rarefaction region is represented by the lower portion, and this lower portion is called the trough, right? So compression and rarefaction. After compression, the rarefaction is formed. After rarefaction, compression is formed. So here the sound wave is propagating through the medium in the form of the compression and the rarefaction. So understand, dear student, what do you mean by the compression and what do you mean by the rarefaction? Due to the variation in the pressure and the density, the sound wave are traveling through the medium. So here the distance between two consecutive compression, or we can say that the distance between two consecutive crests, or distance between two consecutive rarefaction, or we can say that the distance between two consecutive trough is called the wavelength of the sound wave, right? So what is the wavelength of the sound wave? The wavelength of the sound wave is the distance between two consecutive crests or two consecutive trough is called the wavelength. It is represented by a symbol lambda, Greek symbol lambda, Greek letter that is called the lambda. So the wavelength is represented by a symbol, Greek symbol that is a lambda, right? The unit of the wavelength is a meter. The smaller unit of the wavelength is a centimeter, millimeter, angstrom. Angstrom is also a smaller unit of the wavelength. 1 angstrom is equal to 10 raised to minus 10 meter, right? So dear student, understand what do you mean by the wavelength and how the sound wave is propagating through a medium, right? So let us start with the first characteristics of the sound wave, that is called the frequency, right? The frequency of the sound wave. When the sound is propagating through a medium, the density of the medium oscillate between a maximum value and the minimum value, right? So here the variation, the sound wave is traveling through a medium due to the variation of the density, and the density of the medium is oscillating between the some maximum value and to the minimum value, right? So if the change in the density of the medium from the maximum value to the minimum value and again to the maximum value is called the one oscillation. So suppose we consider the maximum value density here or minimum value here. So what is the one oscillation from the minimum value to the maximum value and again from maximum value to the minimum value. So what do you mean by the one oscillation? So change in the density of the medium from the maximum value to the minimum value and again to the maximum value, that is called the one oscillation. So for example, if we consider here the maximum value is here, right, and maximum value to the minimum value is here. So change in the maximum value to the minimum value and again to the maximum value is called the one oscillation, right? Understand what do you mean by the one oscillation? One oscillation is the change in the maximum value of the density to the minimum value of the density and again to the maximum value is called the one oscillation, and the number of oscillation per unit time is called the frequency of the sound wave, right? So number of oscillation in a 1 second, like this type of the number of oscillation in a 1 second from maximum value to the minimum value and again minimum, so that is a one oscillation, right? That is a one oscillation, and the distance travel in a one oscillation is called the wavelength also. So the one oscillation, what do you mean by the one oscillation? Understand, the change in the value of the density from the maximum value to the minimum value and again to the maximum value is called the one oscillation, and the number of oscillations per unit time, the number of oscillations in a 1 second is called the frequency of the sound wave, right? So the frequency of the sound wave is represented by a Greek symbol nu, right? Like this type of the Greek symbol nu, and the unit of the frequency is a hertz, right? So let us see this figure, right? So let us see this figure. Here the number of oscillations completed in a 1 second is represented, and in this figure also the number of oscillations completed in a 1 second is given. So here number of oscillations, calculate the number of oscillations in a 1 second. One from maximum value to the again maximum value, so that is a one oscillation, two oscillation, three oscillation, four oscillation, five and six oscillation. So number of oscillations completed in a 1 second is a 6, and here the number of oscillations from maximum value to the again maximum value one oscillation, and from maximum value to the again maximum value two oscillation. So here the number of oscillation in a 1 second is a 6 and the number of oscillation in a 1 second is 2, right? So this sound wave have a higher frequency, or we can say that the high sound short wavelength. As the frequency is the high, the wavelength of is a short, right? So wavelength is represented by a two consecutive crest or a two consecutive trough, right? So this wavelength, this shorter wavelength, so this sound wave has a shorter wavelength, higher frequency and higher sound, right? And instead of this, if we consider this wavelength number of oscillations completed in this wave sound wave is a 2, right? Compared to this, the wavelength of this wave is a longer wavelength, right? The wavelength of this sound wave is a longer wavelength. It has a low frequency and low sound. So dear student, understand what do you mean by the frequency of the sound wave? The number of oscillations per unit time is called the frequency of the sound wave. As the number of oscillations is higher, the frequency of the sound wave is a higher. So here this sound wave has a higher frequency and has a shorter wavelength, and this sound wave has a lower frequency and the lower wavelength. Now next characteristics of the sound wave is the time period of the sound wave, or we can say that the periodic time of the sound wave. The time taken for the change in the density of the medium from a maximum value to the minimum value and again to the maximum value is the time period of the sound wave. The time required to change the density of the medium from maximum value to the minimum value and again to the maximum value is called the periodic time of the sound wave, or we can say the time period of the sound wave. Or we can say that here we know that the variation change in the density from the medium from the maximum value to the minimum value and again to the maximum value is called the one oscillation, right? So we can define the time period of the sound wave like this also. The time taken for one complete oscillation in the density of the medium is called the time period of the sound wave. Or simply we can define the periodic time of the sound wave is time taken for completion of the one oscillations is called the time period. So periodic time of the sound wave is a time taken for one complete oscillations is called the periodic time. It is represented by a letter capital T and the SI unit of the time period is a second, right? So understand what do you mean by the time period? For example, if we consider this type of the high frequency wave and the low frequency wave. So here time taken to complete a from one oscillation, that is a from maximum value to the minimum value and again maximum value is called the periodic time. So if we considering the time taken to complete a one oscillation, that is the periodic time of the frequency. So if we consider the high frequency wave, it has a low periodic time, and if we considering a low frequency wave, it has a high periodic time. So the frequency and the periodic time are inversely proportional to each other. The periodic time is the reciprocal of the frequency of the sound wave. So we are deriving a relation between the periodic time and the frequency as follow, right? The frequency and the frequency is the number of oscillations completed in a 1 second, and periodic time is a time taken to complete a one oscillation, right? So here if the frequency of the sound wave is a high, we can say that the periodic time of the sound wave is a low, right? And if the frequency of the periodic sound wave is a low, the periodic time of the sound wave is a higher, right? So the frequency and periodic time is inversely proportional to each other. We can represent the periodic time capital T is reciprocal of the frequency nu, right? So T is equal to 1 by nu, or we can say that the frequency is a reciprocal of the periodic time, nu is equal to 1 by T. So dear student, understand two characteristics of the sound wave, frequency and the periodic time. The number of oscillations completed in a unit time is called the frequency of the sound wave, and the time taken to complete a one oscillations is called the periodic time of the sound wave, and the frequency and the periodic time is related to each other. What capital T is equal to 1 by nu, right? Now dear student, let us understand the next characteristics of the sound wave is the pitch and the loudness of the sound. The pitch of the sound, shrillness or flatness depends on the frequency of the vibration. The pitch of the sound, we can say that the shrillness or flatness of the sound depends on the frequency of the vibration. If the frequency of the sound is a high, the sound has a high pitch, and if the frequency is a low, the sound has a low pitch, right? So here the two waves are given to you. One has a shorter wavelength and another has a larger wavelength, and the pitch frequency of the wave is also given to you. So the waves are traveling at about the same speed. So this is the number of each wave that will reach the ear in the hundredth of the second, right? So here the frequency of the shorter wavelength means the lots of wave. It has a high frequency. It has a high sound, right? So if the frequency of the sound wave is a high, we can say that the sound has a high pitch. And if the longer wavelength, that means the shorter frequency, low frequency sound wave is there. So if the frequency of the sound wave is a low, it has a low pitch, right? So since the sound are traveling at about the same speed, the one with the shorter wavelength will go by a more frequently and it has a high frequency or pitch, right? In the other word, If the sound wave has the higher frequency, it has a high. If the sound wave has a shorter wavelength and high frequency, we can say that the more number of waves are reached to the ear, so it has a higher pitch. And in the other word, if we can say that sound wave with the same pitch having a long wavelength or low frequency, it has a lower frequency or lower pitch, right? We can say that the sound is a low sound, right? So the loudness of the sound depends on the amplitude of the vibration. What do you mean by the amplitude? We will discuss later on in this video. But the loudness of the sound depends on the amplitude of the vibration. If the amplitude is bigger, the sound is a loud, and if the amplitude is smaller, the sound is a soft, right? So if the loudness of the amplitude, it has a loud wave, right? Longer wavelength, right? So if the amplitude of the sound wave is a high, bigger, right, we can say that the sound is a loud, and if the amplitude is smaller, the sound is a softer, or we can say that a low sound. Loudness is a low. So here the two figure is given to you. In this, the amplitude of the sound wave is a higher compared to this. So this sound is a louder sound, and this sound is a softer sound. So what do you mean by the amplitude of the sound wave? Let us see the amplitude of the sound wave. So what do you mean by the amplitude of the sound wave? The magnitude of the maximum disturbance in the medium on either side of the mean value is called the amplitude of the sound wave. Or we can say that the amplitude of the sound wave is the height of the crest or a trough. So this from the midpoint, the maximum value of the disturbance is called the amplitude of the sound wave. So the amplitude of the sound wave is the height of the crest or a trough, right? It is represented as a by letter capital A, and the SI unit of the amplitude is same as the unit of the density or pressure. So it is the variation in the density. We can say that the amplitude unit of the amplitude is the same as the unit of the density or a pressure. If we consider the density variation, the unit of the amplitude is a density, and if we consider the pressure variation, the unit of the amplitude is a pressure. So here amplitude of the sound wave is nothing but the maximum value of the disturbance in the medium is called the amplitude of the sound wave, right? Or we can say that the height of the crest or height of the trough is called the amplitude of the sound wave. So let us see, the sound loudness of the sound depends on the amplitude of the variation, right? So if the amplitude here, if you considering this sound wave, the amplitude of the sound wave is a higher, right? So this sound is a loud sound, right? And if the amplitude of the sound wave is a low, it has a soft sound, right? So the pitch of the sound pitch of the sound depends on the frequency. If the frequency of the sound wave is high, the sound has a high pitch, and if the frequency of the sound is low, the sound is a low pitch, right? And the loudness of the sound is depends on the amplitude. If the amplitude of the sound wave is a higher, the sound is a loud, and if the amplitude of the sound wave is a smaller, right, the sound is a soft sound. So dear student, understand these characteristics of the sound wave. First one is the frequency of the sound wave, second one is the time period of the sound wave, third one is the amplitude of the sound wave, and fourth one is the pitch and loudness of the sound wave. Now last characteristics of the sound wave, that is the speed of the sound wave. The speed of the sound is a different in the different medium. The speed of the sound is more in a solid, less in a liquid, and least in a gaseous medium, right? We know that the sound wave can travel in all the three medium: solids, liquid, and gaseous. But the speed of the sound is different in the different medium. The speed of the sound is more in a solid medium, less in a liquid medium, and least minimum in a gaseous medium. So the speed of the sound also depends on the temperature of the medium. if the temperature of the medium is more, the speed of the sound is a more, right? So here the speed of the sound in the different medium at a specific temperature 25 degrees Celsius temperature given to you. Speed of the sound in a solid medium like a aluminum, steel, iron, brass, glass, right? This in a meter per second given to you for only information, right? No need to remember the value of the speed of the sound, but remember the value of the speed of sound in air. It is a 346 meter per second, right? So here the speed of the sound in a solid medium is a higher, speed of the sound in a liquid is a less compared to the solid medium, and the speed of the gas is a gaseous medium. Speed of the sound in a gaseous medium is a least minimum, right? So what is the relation between the speed v, frequency mu, and the wavelength lambda? So here all the three parameters we were discussed in this video previously, right? What is the speed of the sound, what is the frequency, and the wavelength. What is the frequency of the sound wave? The number of oscillations completed in a 1 second. The number of oscillations completed in a unit time is called the frequency. And what is the wavelength? The distance between the two consecutive compression, or we can say that the distance between two consecutive compression or rarefaction is called the wavelength, right? Or we can say that the distance between the two consecutive crest or trough is called the wavelength. So speed of the sound wave is equal to the wavelength into the frequency, right? So speed of the sound wave v is equal to wavelength of the sound wave lambda into frequency nu. Instead of this frequency nu, we can also write the periodic time. Mu is equal to 1 by t. So we can also write the periodic time. Speed of the sound wave v is equal to lambda divided by periodic time capital T, right? So we know that nu is equal to 1 by capital T. So instead of this nu, if you write 1 by T, we get the speed of the sound wave v is equal to, speed of the sound wave v is equal to lambda divided by capital T, right? So understand, dear student, all the characteristics of the sound wave. The characteristics of the sound wave can be described with the help of the wavelength, frequency, periodic time, amplitude, and the speed of the sound wave. And also the characteristics of the sound wave can be determined with the loudness and the pitch of the sound wave. So dear student, this formula is important for the example also. The example we will discuss later on in this chapter, right? Of all the, to calculate the frequency of the sound wave, to calculate the periodic time of the sound wave, speed of the sound wave. This all the examples session we will discuss later on, right?